In this tutorial, I'll solve problems from section 14.3, which is about double integrals in polar coordinates. So this question here is saying find the volume of a region that lies below the paraboloid z equal x squared plus y squared and above the xy plane and inside the cylinder x squared plus y squared equal 4. This sounds a lot, but let's see how this looks like. So here, this is the paraboloid, as you see this part here, and the part down there is the xy plane, and the cylinder is obvious. So what we want is this area, the area in between the cylinder, the paraboloid, and the xy plane. So how do we find limit of integrals here? If we are speaking about polar here, we have r and we have theta, right? So it looks obvious that theta is going to go all the way from 0 to 2 pi, and r is going to go from, you see the cylinder is going until 2, negative 2 to 2, and the x and y, but we are speaking polar, so it's going to go from 0 to 2, and then because we have pi that's going to go, theta that's going to go between 0 and 2 pi, is going to rotate all the way to the negative 2 and to all sections of the shape. So this question is also equivalent. I just like to make it clear that this is equivalent to saying, okay, find the integral of this function x squared plus y squared, which was the paraboloid, over the region R, where R is bounded by the circle x squared plus y squared equal 4. Why I'm saying this? Because the question could come this way and you need to go the other way around. So what I'm saying is that find the area, the region, the volume under this thing, x squared plus y squared, okay, within the circle down here, within the circle x squared plus y squared equal 4. And sometimes it's confusing. X squared plus y squared is a circle and at the same time is a cylinder. Well, if you're speaking only polar, then it's only a circle, 2D. But if you're speaking 3D, then this could take any value for z. So this means that it's going to be a cylinder. So anyways, we remember that in polar is x squared plus y squared is equal to r squared. dA in polar is r d theta dr. Now construct your integral. It's going to be r squared, because you remember I said here x squared plus y squared. So this is equal to r squared, and dA is equal to this r d theta dr. I put it here, and then I put my limits of integral r equals 0 to r equal 2, and also theta equals 0 to theta equal 2 pi. Now it's a piece of cake. It's just like in Cartesian, because it's only change of r theta instead of having x and y. So I also put my red brackets again here. So we are integrating here with respect to r. We have r squared multiplied by r, which is r cubed. If you do this integral, you get r to the power of 4 over 4. And then the limits of integral, again, I just like to make it clear, r equals 0 and r equal 2. Substitute this, and then after that you get, I don't know why I repeated this. So after that you will get r, you substitute the values, you're going to get 4, and then again you will have the derivative, or the integral of d theta, which is equal to theta, and then substitute your limits of integral 2 pi and 0, you end up with 8 pi. So this was a pretty easy question, but the whole idea of just figuring out what is your limits. So when you're still a cylinder, you have to know that how cylinders like x squared plus y squared, that means it have a radius of 2, paraboloid is above it. It's just, you need to figure out how do you know the limits. Then we have a new question. It says evaluate by changing to polar coordinates. So we have something in Cartesian. It tells you to change it to polar. So dy by dx, we know that this is dA, which we could write in polar as r d theta dr. We know that x squared plus y squared is equal to r squared, and we know, so we know this, so that's easy. So again, I'm just writing it again just to show that this is y and this is x. Just like to make this clear. And then, so we could figure out how to change dy and dx. So we could figure out how to change x squared plus y squared. But the limits here are y equals something to y equals something, and x equals something to x equals something. We want to change it to theta and r. So how do we do this? We have to draw. So when you draw, when we say y equals 0, this is this line here, because we have our y-axis here, our x-axis here, and the 0 and 0 point is here. So here, this is the line where y is equal to 0. So this is the lower limit. And the upper limit, y equal root 4 minus x squared, is this half circle. If you square both sides, you will have y squared equal 4 minus x squared. That's an equation of a circle, but because only we have the positive, because root is always positive, so we only have y positive, then it's only half the circle. So it is between this line and this half circle, and also between x equal -2, obviously, from here to here, right? Now we want to change this to polar. So if we want polar, we're going to start from here. This is our origin. We have r. R is going to go, obviously, because we want all this area. It's not shaded, but it should be shaded. So this is the area here. All this is the area. So we want r to go from 0 all the way to 2, right? This is our maximum point. Wherever you go, r is 2 on this half circle. And we want theta to go, so remember that from here we start to count theta and counterclockwise. So if you go from here all the way to the other side, this is pi. So we want theta to go from 0 to pi. So from that, we know that the region that we are integrating over is from r from 0 to 2, theta from 0 to pi. So also remember that dA equals dx dy. This is in Cartesian. It's equal r d theta dr and polars. So let's write everything in the integral. So we realize how we changed the limits and how we changed x squared plus y squared to r squared. And we put dA here instead of dx dy. We have this. And then we just do u substitution, because remember er squared r. It's just using substitution. Also remember we have our red bracket. You are integrating just with respect to r inside this bracket. So u equal r squared. Just substitution, dr equal du over 2r, and then also you have to change the limits again, and then you have this integral instead. Just evaluate your integral, e to the power of u. Remember that this is exactly the same, where u equal 4 and u equal 0. Substitute those values, you will end up with a number here, this number here. But it's a constant because we are done integrating with respect to r. Anyways, it's a constant number because e to the power of 4 have a numerical value. So this is a constant. We get it outside the integral. We do our integral normally, and we end up with this expression. And this is pretty much the answer for this question.